So, lesson 4.5 is brought to us by a prisoner, number 5380. Gold teeth, big smile. Here we go. We're looking at measures of average. Our stats class, we often simplify this to measures of center. Sometimes we also call this type of measurement central tendency. And what this is we can think back to in 4.4, we talked about a population that we defined by some question we wanted to answer. And we drew from that population a sample using some sort of random process. And from that sample, we collected a data set. And with that data set, we could organize things with stem and leaf plots and grouped frequency distributions and histograms, etc. And now we're going to do some calculations or some measurements from that data set. And one of these particular sets of measurements is called the measure of average. And it tells us things about the data set. So our author has us working through a particular made-up example. And that is that we're looking at a company that claims the average salary of someone who works at the company to be $150,000 per year. And as a potential employee of that company, you might be interested in working there because $150,000 is not a bad salary at all, right? So you say you're working and you find this list of salaries in the trash can, and we're going to do a little analysis on this data set. Notice our author here is talking about measures of central tendency. What I want you to note is that this word average could be four different things. In our textbook, our author has us thinking about it as it could be a calculation of a mean, it could be a median, it could be a mode, or it could be a mid-range. Each one of these four types of measurements tells us something about the average. And it might be that one of them is a better measure of average for the data set than another. Okay, so the first one is the mean. This is the one you're probably thinking about when you hear the word average. It's simply the sum of all the data values divided by how many. This is the formula for that. We use the symbol X bar when we're talking about a sample. If we were talking about a calculation from a population, if we knew that, we would use the symbol mu for population mean. Okay, so what we do is we add up all the data values in the data set. We divide by how many data values are in the data set. So if we look at this data set, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 data values. We'd add these all up and divide by 9. And that will be our mean. Okay, so we're going to do that in Desmos. That's one way to do it. We can also do it in Excel, but I'm going to show you most of this in Desmos. Now, one way we can do this is to create a table of values, or not a table of values, but to create a data set. So I'm going to label it data set A, and I'm going to use brackets. And notice Desmos says, oh, A has 0 elements. And I'm going to type in here my elements. 58,000, comma, 65,000, comma, 944,000, comma. Notice I am not using comma to separate the numbers themselves, like 51,000, I'm not using a comma in that number. That's because Desmos uses commas to separate data values. So what I have done is I've created a list of 9 data values in Desmos. The reason I did it this way is because I can now use these functions under statistics, and I can say, tell me the mean A, and it's calculated for us, $149,777.78. What Desmos has done is it's added up all these data values and divided by how many. It's a handy little feature. We could have used any letter we wanted in Desmos. So the sample mean for that was 147,000. Oops, am I getting that right? It was, let's go back. It was 149,000 $777.78. If we are evaluating the claim of the company that said we pay our employees an average of $150,000, this would say, yep, that's correct. Let me rewrite that so we can actually read that. $149,770.78. But if you pause and look at the data values themselves, you might notice that, in fact, this is not a very good measurement. Newman makes a lot of money relative to everyone else. So let's recalculate the mean if we remove that data value. So what I'm doing is I'm copying and pasting this. I'm going to label this data set B, and I'm going to delete that 944,000, and I'm now going to calculate the mean of data set B, which has Newman's salary removed from it. So I'm writing down X bar here is 50,500. Wow, that's a drastically different number, right? A much different average when we take out just the one salary. So this is a much better measurement of the average or typical salary. Typical is probably another good word for average. This looks like a good measurement of the average salary. Whereas this one does not when we look at the individual data values. That tells us something about that measurement, the mean as a measurement of average. Now the median is the number when we put all the data values in order from smallest to largest and then count to the middle number. We are not going to do this by hand, so you can ignore this. We're just going to go to Desmos and we're going to type median. Or you could click functions and note that the median thing is there. So I'm going to find the median for data set A that included Newman's salary. That value is 53,000. Note that's pretty close to the mean without Newman's salary in it. It's very close to the initial mean. Question 4, we don't even need to bother with. It's saying, hey, what happens if there's an even number of data values? How would you find the median? Well, you find the mean of the middle two data values. You add those two together. But we don't need to worry about that because we're letting Desmos do all the calculations for us. Same thing here. We're letting Desmos do it all for us. Okay, so we're going to remove Newman's salary again, and we're going to calculate the median salary with his salary removed. So for us, that's the median of B. Oh, look at that. It's essentially the same salary, 52,500. There's basically no difference between these medians. Tells us two things. Number one, it leads to the definition of an outlier. So the outlier is a sample data value or data values that are very far away from the majority of the values. This outlier, we could talk about it as being a large number or small number relative to all the other data values. And 944,000 was way higher than all of the other salaries. So it was a relatively large value. And it had no effect, or essentially no effect, on the median, right? It remained relatively unchanged. What we say then is that the median is resistant to outliers. So if we want to talk about the average salary of a data set, and we note that there are outliers in the data set, then we'd want to talk about the median as the best measurement of outliers, or of the average. If there are no outliers, then the mean is always the better measure. So let's see, find the median of the salaries of annual interest rate without Newman's. Find the median salary without Newman's if Kramer quits to start his own company. So we're supposed to go back and get rid of Kramer's salary. Kramer's salary was $20,000, I believe. This one. So let's make a new data set, and we're just going to show you. We're going to call this one C, and we're going to delete this one, and you'll see that even when we do that, median of C, we actually have the exact same salary as the mean when there was no when the 944,000 data value was taken out.